Hello, friends. We know that there are colossal objects in our space known as black hole and neutron stars, and they actually exhibit remarkable properties. So we pretty much know, how the black holes are formed and how neutron stars are formed. So what we are going to discuss today is this particular object. As you can see, the name is very complex. It is called J1858.6-0814. This object is actually is a neutron star which thinks it's a black hole. And why a neutron star will think it's a black hole, we will actually understand and show you actually what is going on in this particular object. But first, let's discuss about the accretion disk of black hole. Usually when the black hole is formed, before it actually formed, it was actually a star. And that star rotates on its axis. And as the size of the large stars, which are many times, at least 10 to 15 times the size of sun, shrink down to something which is like a 10 kilometer or 5 kilometer small ball, which we call black hole, the entire mass of the star actually falls into this black hole. And since it is rotating at certain speed, and as the size decreases, in order to basically conserve the angular momentum, the rate of rotation of this resultant black hole is extremely fast. We don't know too much about this, but we believe that the rotation may be equal to the speed of light at the event horizon, and that is the reason that any matter which falls into the black hole which is beyond the event horizon becomes invisible, because at the event horizon the speed of rotation is equal to the speed of light itself. So these extreme body black hole have extreme properties, and one of the property is the rate of rotation. And these black holes have the huge potential to basically grow. They can actually keep consuming things, keep absorbing things, and keep growing. There is no upper limit so far that we know for. We have seen ultra massive black holes which are almost 100 billion times the mass of sun. However, in the center of every galaxy, we have supermassive black holes, and if you measure the mass of these colossal beasts, you would know that of any galaxy, 99.9% mass of the entire galaxy lies in the central supermassive black hole or ultramassive black hole. So, if you have a larger black hole, you will have a larger galaxy. So, nutshell, these bodies are very extreme. They have a potential to grow bigger. But then how does it grow bigger? It's basically by absorbing material from open space. And as the material fall into the black hole, and since black hole has such a huge gravity, it actually bends the space-time. And as the material starts to fall into the black hole, it starts rotating, because the entire space-time, the space itself is very heavily being rotated also around the black hole. So the material which is actually in this accretion disk is also moving very, very rapidly. And this is actually made of subatomic particles, because at this high speed, which is almost one third the speed of light at which this material is moving, and therefore there is the particle which are forming this accretion disk are essentially the subatomic particles, and they are heated up to trillions of degrees of temperature. So although the black hole in the middle is black, it does not show any activity, but the accretion disk which surrounds it basically shows that there is a black hole here. And the accretion disk actually emit all kinds of radiation, starting from gamma ray to x-ray, and that's how we know that there is a black hole. And the accretion disk also is very peculiar, very, very specific to black hole, and normally we see these accretion disk around the black hole itself. However, scientists have been able to find a neutron star which exhibits similar properties like a black hole. That is why the topic of the video today is that there is a neutron star out there in the universe which thinks it's a black hole. So we'll come to that in a moment. Let us understand what is a neutron star. Well, neutron star is sort of a midway step to become a black hole. So, in nutshell, a neutron star is something which is sort of a failed black hole, and there is an upper limit. And if the neutron star size goes beyond 2.5 times the mass of sun, it will actually collapse into a black hole. So usually neutron stars are not so extreme like a black hole, but they are fairly extreme. And if the sun has to become a neutron star, the neutron star resultant neutron star will not be more than 10 kilometers in diameter. So the entire sun will shrink down into a neutron star which is about 10 kilometers. This 10 kilometers is less than any normal city today. So you can imagine that the entire mass of sun will shrink down into a neutron star, and therefore a 10-kilometer body will exert the entire gravity of the sun. So neutron stars are also very extreme object, but not as extreme as a black hole. And these are the perfect spheres. These are the examples of matter existing in perfect spheres. And as you know, neutron stars are made entirely of neutrons, and their structures are supported by the neutron degeneration force. And if the neutron degeneration force also will not be able to hold the pressure of the gravity, if the mass of the neutron star is more than 2.5 times the mass of sun. Therefore, when a neutron star absorbs a material, it keeps increasing in mass until and unless it actually reaches 2.5 times the mass of sun. At that point in time, it explodes into a type A supernova and then becomes a black hole. So neutron star is a eventual midway to becoming a black hole. That's why I call that neutron star is very similar to black hole, but not all the way. However, there is a neutron star which thinks it's a black hole simply because scientists have been able to locate this object. As I said, very intuitive name, J1858.6-0814. Now this object is actually a neutron star because we see that there is a neutron star in the middle. However, this neutron star is surrounded by an accretion disk. Usually we see the accretion disk around the black holes, but this neutron star is also having an accretion disk, which is very surprising. Usually what happens is that the behavior of neutron star is slightly different because these are not so extreme like a black hole. Black hole even bends light. Black hole even does not allow light to escape. Black holes are so powerful that even light cannot escape, whereas neutron stars are not so extreme. So having an accretion disk around a neutron star is very surprising. However, this object is having an accretion disk, and the accretion disk is similar to a black hole accretion disk, which is moving at very high speed, very rapid. It comprises of subatomic particle moving rapidly and also giving out all kinds of radiation starting from gamma ray, X-rays. Very energetic outburst is being noticed coming out from the accretion disk around this neutron star. So we don't know too much what are the reasons behind this accretion disk forming around a neutron star, because typically when we look around, we will see accretion disk around black holes only. We have never seen a neutron star with an accretion disk. So this is a very surprising fact. Scientists are baffled and they are doing their research and trying to find out if a neutron star, or if there are other examples of neutron star hosting accretion disk. Then we will actually start understanding more about these extreme bodies or also find similarity between black holes and neutron star, and where the boundary between the two basically diminish. So I think this is going to give us more information. Research is on. However, I like to know what do you think about this find. If you have any more inputs, I will be more than eager to hear from you. And friends, thanks for watching, and I will catch you again in the science show in the next edition. Until then, bye bye for now.